Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin. I'm going to cover a really interesting geometric problem in a Calc 3 class, and this is going to be the distance from a point to a line. So I want to find the distance from this point 3, -1, 4, to the line defined by this vector value function r of t, which is going to be 4 minus ti, 3 plus 2tj, and minus 5 plus 3tk. Now, let's look at this again, like I said, geometrically. What I have is I have a point somewhere out in space, and this is going to be that point 3 minus 1, 4. And then out off of that point, hopefully, sometimes they do land through it, but not in this case. But out from that point, what we have is we're going to have a line right here. Now, this line is defined by this vector value function, but we also know that we can define it parametrically by x is equal to 4 minus t, y is equal to 3 plus 2t, and then z is equal to minus 5 plus 3t. So they mean exactly the same thing. All right, so here is my method. I'm going to do it instead of using projections. I'm going to do it very geometrically. And what I want to do is I want to find, basically we're looking for the perpendicular distance from this point to this line. So what I'm going to do this is I'm going to create a plane that I know I can send through this point, orthogonal or perpendicular to that line. So I'm going to do this plane. I'm going to kind of draw it like this. We're going to have a plane that looks like so. And what I know it's going to be is it's going to be perpendicular or orthogonal to that line. So I need to find that plane. So that plane is going to have to be defined by, well, we know we need, it's got to be a times x minus x naught plus b times y minus y naught plus c times z minus z naught is going to be equal to 0. And we know that the A, B, and C have to come from, this line. It has to be perpendicular to this line. So the A, B, and C is going to be this -1, this 2, and then also this 3. So this is going to be -1, this B is going to be 2, and then C is going to be equal to 3. And then we know we're going to have to do, x minus x naught plus, y minus y naught plus z minus z naught is equal to 0. And the x naught, y naught, and z naught have to be here. So again, what I'm trying to do is I want to plane through this point perpendicular to that line. So it's going to have to go through this, 3 minus a -1 and then -4. Now, expanding this line, we're going to have minus x plus 3 plus 2y plus 2 plus 3z minus 12 is equal to 0. And then finally, we're going to have this plane. Let's keep it all in this pink. We have minus x plus 2y plus 3z is equal to 7. So that defines, this plane here. All right. So now that I have that, I can find the intersection of this blue line in this plane. I can figure out when does that happen, because now if I have these 2 points, the intersection between that line and the plane, I know that they're going to be the shortest distance because of the plane is perpendicular. So let's find that point second. So let's find the intersection point. Now, in order to do that, we know that that is when, this line right here intersects this plane right here. It's going to happen at the point of intersection. So what I'm going to do is instead of x, y, and z, I'm going to write in, the values of the lines. So I have, this is going to be minus, we have x plus 2 times y plus 3 times z is equal to 7, where, your x comes from here, so 4 minus t, your y comes from here, 3 plus 2t, and then finally, similarly, minus 5 plus 3t comes from that z. Okay. Resolving this intersection point, what we're going to get here is minus 4 plus t plus 6 plus 4t minus 15 plus 9t is equal to 9. All the t's, 1, 4, 9 is going to give us 9 plus 5, which is 14t. Oh, this is still 7 over here. 7. And then minus 4 plus 6 is negative 2. So this is going to be minus 13. Send it to the other side. It's going to be equal to 20. So this is 20 over 14, or I can say that this is 10 over 7. Now, we can say that that is the parameter for which the point intersects this line, or you can say at that particular time. So at time 10 over 7, that's going to be our point. So our actual point is going to be, plugging this back into that line. We know x is going to be equal to 4 minus, 10 sevenths. Y is going to be equal to 3 plus, 2 times 10 sevenths, or 20 sevenths. And then z is going to be equal to minus 5 plus 3 times this, so it's going to be 30 over 7. Or I can say that this is going to happen at, I'm just going to write this in point form. X comma y comma z is going to be, this will simplify to 18 over 7. This will simplify to 41 over 7. And this will simplify to minus 5 over 7. So that's what this point is. That is that point right there. Finally, we can find this distance. So if I want to find this distance right here, this distance d, we know we can set it up as a vector as, this point minus this point, or we can just use the distance formula, which is still the magnitude of that vector. So then finally that distance is going to be equal to the square root of, let's do this minus this, final minus initial. So 18 minus 7. So really I'm trying to say the vector in this direction. 18 minus 7, this is minus 3 squared plus 41 over 7 minus a minus 1 squared plus minus 5 over 7 minus a 4 squared. And simplifying this is going to give us minus 3 over 7 squared plus 48 over 7 squared plus, nice, minus 33 over 7 squared. So we're going to have, 9 over 49 plus 2,304 over 49 plus 1089 over 49. I didn't say it was going to be a nice integer. So what we get here is we get the square root of 3402 all over 49. And if you want to pull out some perfect squares, clearly, the square root of 49 is 7. And this is 81 times 42. So the square root of 81 is going to be 9 times, the square root of 42, because 42 has no perfect squares. So that is the distance from this point to this line. So if you like the content, please subscribe.